Hello students, in this video we will learn about sequence and how to generate a sequence. So first of all, what is a sequence? It is a group of numbers following a specific pattern. Each number in the sequence is called a term. Sequence can be classified into two types. One is finite and another is infinite. In the finite sequence, terms are countable, whereas in infinite sequence, the terms cannot be counted. Finite sequence stops after a certain number of terms, whereas infinite sequence goes on and on endlessly. We can identify whether the sequence is a finite or infinite by three dots at the end. If the sequence does not have three dots at the end, then it is a finite sequence. But if it has three dots at the end, then it is an infinite sequence, meaning the sequence is going on and on. Three dots do not appear at the end in the example shown for finite sequence. On the other hand, three dots at the end in the example of infinite sequence indicates that the sequence continues endlessly. If we take any two terms of a sequence back to back, they are called consecutive terms. Here, the term 8 is just after the term 4. So 4 and 8 are called consecutive terms. In the same way, 12 comes just after 8 in this sequence. So 8 and 12 are also consecutive terms of the sequence. Similarly, 16 and 20 are also consecutive terms. As we have seen, a sequence follows a particular pattern. That means it has a specific rule. So what is a rule for a sequence? Let's take an example of a sequence 4, 7, 10, 13, 16. Now if we start from 4 and go to the next term, we can see that it is obtained by adding 3. In the same way, after 7, its next term is again obtained by adding 3. Again, adding 3 to number 10, the next term in the sequence is obtained. So, the term to term rule or the specific pattern of the sequence is adding 3. So, if we add 3 to 13, we get the next term 16. In the same way, we can get any number of terms required in the sequence. If we are to find two next terms in this sequence after 16, then we add 3 to 16 to get the next term 19. Then again we add 3 to 19 to get the next term 22. In the similar way, we can obtain any number of terms that we required in a sequence based on its rule. Let's take another example for the rule of a sequence. Now, in this example, we are given with the first term of the sequence, that is 2, and the rule for the sequence, the term to term rule, is multiply by 3 and then subtract 2. So every time we have to follow these two operations to get the next term of the sequence. So if we multiply 3 by 2, that is 6, and then we subtract 2 from it, we get 4. So the next term after 2 is 4. Now to get the next term of this sequence after 4, we multiply 4 by 3, we get 12, and then we subtract 2, that is 10 is the next term of this sequence. In the similar way, to get the next consecutive term, we multiply 10 by 3, that gives 30, and then we subtract 2, that is 28. Now you can try and calculate the next term in the sequence after 28. Yes, you have guessed it correctly, it is 82. Now we see some pattern as a sequence. That means we can create beautiful designs using sequence. Here we take a simple pattern in which the first pattern is having 3 dots, second pattern is having 5 dots, and third pattern is having 7 dots. So we can guess the term to term rule for this pattern, that is add 2. Addition of 2 is the rule for this sequence. So to get the next pattern in this sequence, that is pattern 4, we will require 7 plus 2, that is 9 dots. In this way we can create different patterns based on the sequence. Moving ahead in the video, our next topic is representing simple function. First of all, what is a function? A function is a relationship between two sets of number. We can say a function is a relation between two different sequences. Let's say we have two sets of numbers 1, 2, 3 in one set, and our function we take as an example as multiplication by 5. So if we take one number from the given set and if we multiply it by 5, we get the result as 5. If we take the second number from the given set and multiply by 5, we get another number, that is 10. We take 3 from the first set of numbers, and if we apply the function, we get 15 as the answer. So here the set of numbers from which we were taking the numbers is called input, and the set of numbers that we obtained as our result after applying the relationship or the function, it is called output. And output sets, each number of input is related to one of the numbers in the output set, and this is called mapping of numbers of function. Our input set of numbers is 21, 24, and 30, and the function is subtraction of 4. So if we apply the function to the first number 21, then 21 minus 4 gives 17. In the same way, if we apply the function of minus 4 to second number 24, we get the answer as 20, or we get the output as 20. If we apply the function to the third number of the input set, we get the answer as 26. Okay, now let us learn the construction of expressions. Before that, we need to learn the term variable. Variable is a letter used to represent unknown numbers. In any given situation, when we don't know a particular number, then we use a letter which is called a variable in place of that number. So let's take an example. There are certain number of students in a class. So we don't know the number of students in a class. So in such case, we take number of students in a class as a letter, an alphabet. Here we take it as S. So this S is called variable. Now, on a particular day, there are 4 students absent. So on that day, the number of students present in a class can be known by an expression. So there are 4 students less than the number of students in the class. So we get the number of students present on that day as S minus 4. This S minus 4 is called expression. Let's take of expressions. We are given that the age of Matthew is unknown. So we have to take a variable, a letter, as the age of Matthew. So we take x as the variable. Now it is given that David is 4 years older than Matthew. That means the age of David can be expressed by an expression that is x plus 4. Adam is 2 years younger than Matthew. Then the age of Adam can be expressed by the expression x minus 2 years. Catherine is 3 times older than Matthew. So the age of Catherine can be expressed by the expression 3x years using the variable number of age of Matthew. In the same way, if Ella is half the Matthew's age, then the age of Ella can be expressed as x upon 2 years. Now, by somehow, we got to know that the age of Matthew is 14 years. So, if we know the value of variable by some calculation or some available data, then all these expressions can be evaluated. We can get the age of David as 14 plus 4, that is 18 years. The age of Adam, which was x minus 2, and we know the value of x now is 14. So 14 minus 2, age of Adam is 12 years. In the similar way, age of Catherine is 3 times 14, that is 42 years. And the age of Ella is 14 by 2, that is 7 years. So this is how expressions are used in case when the numbers are unknown, and once finding the value of that unknown, various other expressions based on the first expression can be solved. Now these expressions are very much useful in deriving and using formulae. The formula is a mathematical rule that shows the relationship between any two quantities or any two variables. Let us take an example. We all are aware with the formula for area of a rectangle, that is length times its width. So we can use alphabets or variables to represent or to derive this formula. That is, we can write A as L times W. Now, in a particular situation, we are given that length of the rectangle is 7 centimeter and width of the rectangle is 3 centimeter. Then we can use this formula to find the area of this rectangle. So we just substitute the value of L as 7 and value of W as 3. So area is 7 times 3, that is 21 centimeter square. So this is how expressions are used in deriving and using formulae. Thank you.